In the previous lecture, we were discussing about linear combinations, linear independence of vectors, independence or dependence, you can say. So we saw that a vector set of vectors can be linearly independent or not. For example, let me example. We did examples. Let's have another example. Let S be defined by 1, 1, 1, 1 minus 1, 3, and 1, 0, 0. Is this set linearly independent or not? How can we find whether this set is linearly independent or not? You tell me, anyone.
First, you create a coefficient matrix with all of these vectors being the columns, and then you find the determinant.
So these are the vectors, we call them v1, v2, v3, for example. And then in order to prove that whether these sets, these vectors are linearly independent or not, what we do, we write a homogeneous linear system, C1, B1, C2, B2, plus C3, B3. Homogeneous linear system, kind of this expression. And by inserting these things into this, what do we obtain here? We obtain C1, 1, 1, 1, plus C2, 1 minus 1, 3, plus C3, 1, 0, 0, okay, equal to 0, 0, 0. Now what is this? This is basically a homogeneous linear system, and how we can find the values of C1, C2, C3. In order to find it, we write the corresponding augmented matrix 1, 1, 1, 1 minus 3, 0, 1 minus 1, 3, and then 1, 0, 0, and the right hand side vector is 0, 0, 0. Okay. After solving it by reducing this augmented matrix into echelon or reduced echelon form, we can find the values of C1, C2, and C3. If all the values C1, C2, C3 are 0, then we say that these vectors are linearly independent. They have no relation with each other. If at least one of these constants is non-zero, then we say that these vectors are linearly dependent. Okay, and one vector can be written as a linear combination of other vectors. So this was we were doing in the previous lecture. Now today we are going to generalize this thing to some other spaces. ये जो सेट है, ये सेट था यूक्लिडियन स्पेस का, which is Q. Okay. Now we can define any other kind of sets. For example, from the matrices or from the polynomials. We discussed the set of polynomials, vector spaces of polynomials, vector spaces of matrices. So we can prove, if we are given some matrices, we can prove whether those matrices are linearly independent or not. So let me give you some example of this thing. Now let's say S be a set which contain matrices 1, 0, 1, 2, and 1, 2, 2, 1, and 0, 1, 2, 1. This is your set, and this is a subset of M22. What is M22? Is a set of all 2 cross 2 matrices. Now we have to check whether this set is linearly independent or not. What we do, we write the same kind of expression, C1 A. For example, this matrix is A plus C2 B. This matrix is B plus C3 C. This matrix is C, and we put it equal to null matrix. Now, as the elements, the nature of the elements have been changed, So the expression would remain same, but the elements which are in this set, they will appear here. Okay. Now, after inserting these values, and this is your null matrix of the same order, 0, 0, 0, 0. I hope you know that how to solve these two things, this expression. You put the values of A here, you multiply C1 with C1 here in the 4 places of this matrix, and then C2, C3. How many equations will you get? You'll get 4 equations in C1, C2, C3, C4. And that will be your homogeneous linear system. Okay. In order to solve that homogeneous linear system, what you do, you write the corresponding augmented matrix and solve for C1, C2, and C3. If C1, C2, and C3, they give you, they're all 0, then we say that these matrices or this set of matrices is linearly independent. I hope you can do it.
Sir, sorry, आप repeat कर सकते हैं कि if what happens, then they're linearly independent?
If the values of these coefficients, C1, C2, and C3, they're all 0, then this set is linearly independent. But these matrices are linearly independent. They don't have any relation with each other. Okay.
Okay.
You'll get 4 equations because you see that here what you get C1, 0, C1, 2, C1, okay, plus the other one C2, 2, C2, 2, C2, and C2, okay, plus the next one is 0, C3, 2, C3, and then C3 equal to 0, 0, 0, and 0. Now, what do you get here after adding these matrices on the left hand side and then equating it to the right hand side 0, 0, 0, 0? What do you get? C1 plus C2 plus no, equal to 0. No, okay. This equation क्या है? Second component 0, 2C2 plus C3 equal to 0. And the third component is C1 plus 2C2 plus 2C3 equal to 0. And the fourth component is 2C1 plus C2 plus C3 equal to 0. Now, what is this? This is a homogeneous linear system. Now, you can solve this homogeneous linear system and you can find the values of C1, C2, and C3. If all C1, C2, C3 are equal to 0, then we say that the set is linearly independent. Okay? I hope you get it.
Sir, ये आपने equations कैसे बनाई?
यार इनको ऐड किया ना कंपोनेंट्स को पहले में ऐड किया फिर इसको इक्वल पुट कर दिया 0 we get fun. When two matrices are equal, two matrices are equal when their corresponding entries are equal.
Equal, right?
Okay, so this is how we can get.
Won't these be dependent? Won't the final answer be that it's linearly dependent?
Independent. If all C's, C1, C2, C3, they're all 0, then we say that the set of matrices is linearly independent. If at least one of C is non-zero, then we say that they are dependent on each other.
Sir, won't we have to? Okay.
And another example of a similar kind for the polynomials. Now, let me have 3 polynomials. For example, x squared plus 1, maybe x squared plus 2x plus 1, and x. So these are 3 polynomials. Okay. And what is the degree of these polynomials? It's basically a set of polynomials of degree less than or equal to 2. Okay. So we call it P1 polynomial, P1 of x. We call it P2 of x, and we call it P3 of x. Okay. Now, we need to check whether these 3 polynomials are linearly independent or not. So what we do, we write again C1, P1 of x plus C2, P2 of x plus C3, P3 of x equal to 0 polynomial. Now, this is basically 0 polynomial. and it should be written as 0x squared plus 0x plus 0. Now, by multiplying the C1 and C2, C3 with these polynomials and comparing the coefficients of like powers of x, we can obtain a linear system of equations in C1, C2, and C3. What do we do here? We write C1 x squared plus 1 plus C2 x squared plus 2x plus 1 plus C3 in x equal to 0. Now, you can separate the coefficients of like powers of x on the left hand side. So we can write C1 plus C2 times x squared plus, now the coefficient of x, it is only, sorry, C2 plus C3 is the coefficient of x, plus the constant term C1 plus C2. Okay, this is the constant term.
2C2 plus C3.
हाँ?
2C2 plus C3 नहीं होगा?
कहाँ पे? यहाँ पे?
हाँ जी सर.
2C2 आएगा, yes. This is 2C2. Now, these are, on the left hand side, we have a polynomial. On the right hand side, we have a zero polynomial. So now comparing the coefficients of like powers of x, okay? Comparing coefficients of like powers of x on both sides. What do we get? We get a homogeneous linear system. So it is C1 plus C2 is equal to 0, and 2C2 plus C3 equal to 0, and then C1 plus C2 equal to 0. What is this? This is a homogeneous linear system. After solving it, we can decide whether this set of polynomials is linearly independent or not. This is in fact a polynomial subset of P2 of x. Okay? Set of polynomial of degree less than or equal to 2. So it depends what is the nature of elements in the set. Then accordingly, we try to find whether they are linearly independent or not. I hope you get it now. If you have any question, you can.
सर क्विज के बारे में क्वेश्चन है छोटा सा, शायद पहले पूछ लिया किसी ने, लेकिन शायद आपको पता है आउटलुक डाउन है, तो अगर कुछ हो जाता है कनेक्टिविटी या किसी तरह का इशू, तो जो नंबर्स आपने दिए उन्हीं पे कांटेक्ट करें या
I'll announce once again at the start of the quiz. Now, we were talking about the vectors in Euclidean spaces and then vector spaces and subspaces. Euclidean spaces, vectors. There are some basic concepts related to vectors as well, which I did not tell you before. Let's quickly revise them. They are basically very easy concepts of a thing. For example, length of a vector. In 2 dimension, in your earlier classes, in intermediate or in A levels, O levels, you might have studied, if you have any vector in 2D, what is the length of this vector? How can we calculate? If the components of this vector is are basically x1, x2, and this is 0. How can we calculate the length of this vector? Anyone?
Just square them and add them and take under root.
So this is x1 square plus x2 square scaling. This is basically d, which is the length of this vector from origin. If we call it x vector, this is length of this vector. Now, in linear algebra and in, you can say that in formal mathematics, we need in Euclidean spaces, basically, we need a generalized kind of notation for the length of a vector. Now, from now on, the length of a vector is called norm of a vector. Okay. From now on, the length, you will call it norm. Okay. And norm is defined by and denoted in this way. If you want to calculate the length of this vector, the formula is same, but the notation is changed now. So this is how you denote the length of a vector. These double bars on both sides, and in middle you have to write that vector. Okay, so this is how we define the lengths. We call them norms. Now, if we have a vector in Rn, what would be the length of that vector? That would be x1 square plus x2 square plus so on plus xn square, where x vector is what? It is x1, x2, so on, xn, which belongs to Rn. This is how we define the norm of a vector, means length of a vector. Similarly, the distance between two vectors, already if we have 2 points, for example, x, y, this is your x, and we have another vector, this one, which is y vector. Okay? Its components are y1 and y2. If we want to calculate the distance between these two vectors, for example, this distance, then how can we calculate it? It is nothing but x1 minus y1 whole square plus x2 minus y2 whole square. Okay? But now in norm, how do we define it? We define is the distance between x vector and y vector. This is how we define it now. Norm of x minus y means distance between x minus x and y. Okay, and this is again the same formula. This one, x1 minus y1 whole square plus x2 minus y2 whole square, and plus so on. If we have these two vectors in Euclidean space n, Rn, then the last one would be xn minus yn whole square. So this will be the distance between two vectors. Okay. Sometimes in books, they also define it in this way, d of x comma y. Okay. Remember this. So the length of a vector has certain properties, or the norm of a vector has certain properties. What properties are those? Let me discuss those properties. If you have any question, you can ask. Properties of norm. The distance, some basic properties of a norm is what? First is norm of any vector is greater than or equal to 0. Its length, and you are taking the squares, so it cannot be negative. So it will always be greater than or equal to 0. And when this thing is 0, it is only possible all the components of that vector are 0. Okay. The length of a 0 vector is only 0. Otherwise, if you have a non-zero vector, its length must be greater than 0. This is the first property. Natural kind of common sense properties you have to remember. The second property is norm, or the distance is what? It is commutative. Let me, it's obvious. Let me see second property. Let me confirm it. This one is not the property. The property is this one is second property. Norm of any length of any vector is always positive. Length of the vector is 0 if and only if the vector is 0 itself. The third property is that some scalar times some vector, the norm of a scalar multiple of a vector is equal to the absolute value of that scalar times the norm of that vector. Okay. Because this length is always positive, so it might be possible that the scalar is negative. So that's why we are putting here an absolute on the scale, because we have to make it positive. Lengths are always positive, times the length of that x vector. Okay. Geometrically, what does it mean? If you have some vector here, x vector, okay, and you multiply this vector with some scalar k, then it will be scaled by a factor of k. So now the norm of this vector means length of this vector is this, and the length of this vector should be k times the length of x. Geometrically, this is so. The next thing is the next property is what? Next property is basically called triangular inequality, and it is that norm length of the sum of two vectors is always less than or equal to the length of x plus length of y. We'll prove this property later on. This is called triangular inequality.
ये तो पाइथागोरस थ्योरम से नहीं प्रूव हो जाएगी ये पाइथागोरस थ्योरम की वजह से
Basically, Pythagoras theorem is something different. If we have a Pythagoras theorem, we'll prove that thing also. But this triangular inequality holds for any kind of triangle, whether it is a right angle triangle or not. Okay, what does it mean? Length of one side, and this is the length of some other side. Okay, the third length is what? It is x plus this thing. If we take the length of this side is always less than the sum of lengths of other two sides. Okay. This is what triangular inequality is geometrically. Even if you have a right angle triangle, then it is you know that it is, if it is your base, this is your height, and this is your hypotenuse, then you know that the length of hypotenuse is what? Is equal to the, length of this hypotenuse is always less than the sum of the length of a base plus the length of the perpendicular. Pythagoras theorem is what? It is basically that the scale of this side is equal to the sum of scale of A and B. That is different, but this is different. This is triangular inequality. This holds for any kind of triangle. किसी एक साइड की लेंथ जो होगी वो बाकी दोनों साइड्स की लेंथ के सम से डेफिनेटली क्या होगी? लेस देन और इक्वल. लेस देन और इक्वल क्यों कहते हैं? अगर आपके पास कोई एक साइड आप जीरो कर दें तो फिर इक्वालिटी होल्ड कर देती है. ठीक है, अदरवाइज इक्वालिटी डज नॉट होल्ड. अगर आप पाइथागोरस थ्योरम देखें इसी केस में, तो पाइथागोरस थ्योरम में क्या होगा कि आपका x square x plus y norm square this must be equal to norm of x square plus norm of y whole norm of y square. This is your Pythagoras theorem. Okay? And Pythagoras theorem is different from this triangular inequality. I hope you get it. If you have any confusion, you can ask me. If you have this, then you cannot write from this, you cannot write x plus y is equal to x plus y. I hope you understand. Why cannot we write it? It is true for a particular case. We'll discuss that case later on. Okay. So these are some of the basic properties of norm, length of a vector. Now, there are some other kinds of lengths as well. This is basically, these are the properties of the usual Euclidean norm. So we can define norms in some other ways. If you have any x belongs to Rn, then the norm of x, which I defined here earlier, x1 square plus x2 square plus so on plus xn square. This is a particular norm, and we call it Euclidean norm. And usually it is denoted as x norm base 2 here. You have to put a 2 here in order to show that this is a Euclidean norm. Okay? Because we take squares and we take square root. Okay? So that's why we call it Euclidean norm. There are other kind of norms. This is the first one. There is another kind of norm which we call L1 norm. Okay. L1 norm or the L1 norm. L1 norm is what? In that case, you have to write here 1. Okay. X norm 1. And it is nothing but summation I from 1 to n mod of xi. This is another kind of length which can be used in certain applications. And what is this? This is basically you just take the sum of all the components of that vector. This is called 1 norm. Okay.
इसके आंसर सेम होते हैं
जी नहीं.
और
Their answers are not same.
सर मुझे समझ नहीं आ रहा ये यूक्लिडियन नॉर्म में फर्क क्या है?
यूक्लिडियन नॉर्म में आप क्या करते हो? यहाँ पे सॉरी मॉड वैल्यू भी आएगी. You have to take the mod value. Because the summation is sum from I to n mod of each component of that vector. You take this in this way. This is your 1 norm and this is your Euclidean norm. Euclidean norm और इसमें क्या फर्क होता है? Let me define another kind of norm which is called P norm. P norm is nothing but x1 square plus x2 square plus square नहीं होता P होता P I think P x1 P x2 P and so on plus xn P whole raised power 1 over P. In short, यहाँ पे mod भी हम लगाएंगे basically mod भी आएगा. In short, you can define this norm as summation I from 1 to n, 1 to n, 1 to n, mod of xi power p and whole power 1 over p. This is called P norm. Okay. Now, geometrically, what are these norms? Another norm, let me give you the definitions of all these norms, then I shall show you what is their meaning geometrically. Another kind of norm is infinity norm, and we denote it by x norm subscript infinity. And this is called, it is basically maximum of I from 1 to n mod of xi. This is called infinity norm or maximum norm. You can see that. But this is called infinity norm. Now, what kind of these norms are basically geometrically? Let me.
Notation नहीं समझ आई जो आपने कहा है कि I is less than n and greater than 1 maximum. इसका क्या मतलब है?
इसका मतलब है कि अगर आपके पास x1, x2, so on, xn है ना, इन सारों में से जो मैक्सिमम है उसकी वैल्यू ले, उसका एब्सोल्यूट वैल्यू ले। मसलन आपके पास ये x इंफिनिटी नॉर्म, अगर आपके पास 1, -2, 3, 5 और मे बी -15, ठीक है, तो ये आपके पास x वेक्टर है। इसका मैक्सिमम मींस x, इंफिनिटी नॉर्म क्या होगा?
15?
Yes. Its maximum or infinity norm is 15. You choose the maximum, absolute value of the maximum component from I120. Okay?
Yes, sir.
This is how we take this norm. You got it? Any question?
No.
Okay. Now, geometrically, they are slightly different norms. What does this mean geometrically? Geometrically, L1 norm is basically if we take a unit norm, means any kind of norm here, and its length is 1. Okay. If we take a unit norm, then the L1 norm is what? It is basically a unit scale. This one, where it is 1, 1, -1, and -1. This one. If we take the Euclidean norm is equal to 1, what does that mean? That is a circle in this scale. No, this is infinity norm. This is your x infinity, this scale. The scale is your L infinity norm. Yes. If we take infinity norm of any vector, all the vectors is equal to 1, then this will be the scale. And this interior, this thing is your L2 norm. This is your, so it's L2 norm, x2 norm. All the other norms means xp norm. For example, if you take x3 norm, means आप each component की absolute value का cube लें और फिर cube root लें, तो वो थोड़ा सा क्या होगा, यहाँ से slightly circle से थोड़ा सा यहाँ से kind of elliptic होगा।
सर 340 हो गए हैं तो
4 नॉर्म क्या होगा आपका? सर्कल से थोड़ा सा मजीद बेहतर होगा। So this will be your x4 norm, and so on. When this norm goes to infinity, you will have this scale. What is
please?
the maximum norm is this. This is your x1 norm. If you put it equal to 1. This is how they change. If you have any question, please
I think someone's unmuted. I think.
Mute your mic. So it's a time of quiz. Quiz I think 440. LMS पे 440 पे quiz open हो जाएगा. You start doing quiz, and we'll continue discussing these concepts in the next lecture.